Acoustic imaging is a relatively new technology. The most important thing about it, in the simplest form, it's a device which allows you to see sound. Essentially, you can use a camera to locate, for example, a compressed air leak, and it will superimpose a marker on the screen to show you exactly where that problem is.
So what kind of sound can it see?
Essentially, ultrasound is moving beyond the realms of human capability of hearing. There's some leaks we can hear, but there are leaks which will be in locations which may be further away, and therefore they're outside of the human hearing capability. So from a distance, and with the Si2 now, the specification is up to 200 meters. The type of pattern which is created by turbulent air movement is what the camera detects.
This is Mike. Mike is raging. He's raging because he has to shut down this industrial plant again. He needs to carry out routine checks for issues like compressed air leaks, partial discharge, and mechanical faults. But once again, his boss isn't getting it. All his boss sees is the downtime, the lost productivity, the lost profits, and not the vital maintenance work needed to reduce costs. Mike needs a solution that will let him carry out maintenance inspections quickly and, crucially, without compromising productivity. Ten times faster at conducting industrial maintenance inspections compared to traditional methods, and capable of saving facilities an average of £29,500 a year, the FLIR Si series acoustic cameras allow you to check sites for compressed air leaks, partial discharge, and mechanical faults safely, simply, and swiftly. The latest version of FLIR's Si acoustic camera, the Si2, builds on the capabilities of the Si124, and here to tell us all about the latest developments and features is FLIR's technical sales specialist, Jason Cargill. Welcome, Jason.
Thank you very much, Jess. Nice to be back.
Nice to have you back again.
Thank you.
Okay, so for those who don't know, what is acoustic imaging and why is it important?
Acoustic imaging is a relatively new technology. The most important thing about it, in the simplest form, it's a device which allows you to see sound. Essentially, you can use a camera to locate, for example, a compressed air leak, and it will superimpose a marker on the screen to show you exactly where that problem is.
So what kind of sound can it see?
Essentially, ultrasound is moving beyond the realms of human capability of hearing. There's some leaks we can hear, but there are leaks which will be in locations which may be further away, and therefore they're outside of the human hearing capability. So from a distance, and with the Si2 now, the specification is up to 200 meters. The type of pattern which is created by turbulent air movement is what the camera detects. So those sound waves are received by the microphones and converted to a marker on an image.
So today we're talking about FLIR's Si2 acoustic camera.
Yep.
But it isn't FLIR's first acoustic camera, is it? That would be the Si124.
That's correct.
So how does the Si2 build on the capabilities of the Si124?
Well, the Si124 as a product from our perspective was our kind of first foray into the acoustic imaging world.
Yeah.
You know, FLIR as we are, FLIR, forward-looking infrared, we're known as the company that manufactures thermal imaging cameras. So we identified a technology which complemented the thermal side, being acoustic. And we launched a product a number of years ago now, which was the original Si124, which had a tethered cable and a battery pack held on a shoulder strap. We then modified that into and developed it into an integral battery type device. And then this is the first full design with the new technology included. Still 124 microphones, but we've improved the microphones now, so they're more sensitive. But even the ability to be able to stand up like this, you couldn't have done this with the previous model.
Okay.
And the reason this is useful is because you also have a video function on this camera. So if you wanted to point this device at a process or something that you wanted to watch over time, you can do it quite simply. You don't need a tripod. You just need some kind of base to be able to stand the camera up on. In addition to improving the minimum leak rate capability, which now is 0.032 litres per minute, we now have the ability to have built-in lamps so that we can illuminate an area which is darker, because we've also improved the quality of the camera. So the original camera was 5 megapixels. This is now 12 megapixels. The advantage of that is that we also now have an 8 times zoom feature. So when you zoom in onto a better quality screen, the image doesn't pixelate, and you still get all the detail that you need. In addition to, probably one of the biggest ones now, is we can quantify other gases.
Yes.
So the Si124 was only compressed air. So although this device will not detect different types of gas, if you know what type of gas is in the system, you can then quantify multiple gases now. And these include compressed air, obviously, because that was the original, CO2, nitrogen, methane, argon, ammonia, hydrogen, natural gas. So these are all built into the device, and you can select which type of gas to be able to quantify the loss. And, materials like nitrogen, for example, a lot more expensive than compressed air. So identifying leaks in systems with specialist gases can really, really be a big saving.
So there are 3 versions of the Si2. They have slightly different features. So there's one with leak detection, one with partial discharge detection, and one with both. Why has FLIR made this choice?
All the devices look the same. So if you go to the leak detection version, it is, as the name suggests, it's for leak detection.
Yeah.
But it also has an additional function called mechanical. So the mechanical function, which is just selected by pressing a button on the screen, that allows you then to look at exposed bearings. That's quite important at this juncture to say it can't detect sound patterns in enclosed bearings. So if you've got a bearing inside a motor housing, for example, it's not designed for that application.
Okay.
Because obviously the casing of the motor will prevent the sound waves from being emitted. So what we look at in this particular case is exposed bearings. For example, roller bearings and conveyor systems will have exposed bearings on each end. And some companies literally can utilise hundreds, if not thousands, of these rollers. So what the camera does, it uses different technology. So whereas with a leak, for example, you're looking at the leak rate in litres per minute, for example, and then you'll be looking at a cost. We're now using 2 figures called crest factor and ketosis. So crest factor is essentially, if you were to plot a graph, as a bearing begins to fail, the crest factor will increase.
Okay.
And it increases to a point where eventually the bearing will fail. So we have a crest factor figure, which will appear on the screen. And we say, if the crest factor figure is over 6, you need to have a closer look at the bearing that you're looking at. The ketosis figure is a separate measurement. So let's look at, crest factor is kind of the peaks of the signal.
Okay.
The amplitude of the signal. So the higher the peak, the bigger the problem. Ketosis is more like, to simplify, it's more like the density of the signal.
Yeah.
So if you've got a lot of peaks within one shorter area, it's indicative of a potential problem. So we use sound pressure level in decibels, crest factor, and ketosis as 3 parameters when we're looking at bearings. Now, the thing with bearings are, you don't know when it's being installed. You don't have a new baseline to work with most of the time.
Yeah.
But if you detect the ketosis figure above 2, crest factor above 6, and also linked in with a high sound pressure level, then that's really something that's to look further at. If we then move to the partial discharge version, the PD version, that's a much more specialised skill to develop in the field generally. Yeah. But with the PD version, what we've introduced in the Si2 is on-camera analysis. So previously, with the PD version of the Si124, you would have to then download the records to your PC, and then you need to use the software to be able to identify what type of partial discharge and really get the data that you'd be interested in. This is all on camera now. You literally have to press a button on the screen and it will calculate and show you the PD live in the field. But then we have the Pro version, which will do all 3. By far and away, the biggest users we have for this type of device now are kind of manufacturing organisations, companies which are using specialist gases or a lot of compressed air. Because the thing with compressed air is some sites have to maintain a certain pressure level in the system. To be able to do that, they have to run their compressors to a certain level to be able to maintain that figure. If you've got leaks throughout your system, you've then got to increase your output from your compressor. And what that then means is the knock-on effect over time is you're then operating the compressor above what normal conditions might be, which can ultimately reduce the longevity being reduced. And replacing compressors becomes a very, very expensive thing to have to do.
You can find out more about all of FLIR's Si2 acoustic cameras by clicking the links in the description or the link in the box above. Alternatively, please keep watching if you want to find out how it can save you on average £29,500 a year and why it's 10 times quicker. Right. Now, FLIR's marketing literature claims that the Si2 acoustic camera could save facilities about £29,500 a year on average, which is about £10,000 or £15,000 more than the actual cost of the camera. So it seems, if that's true, like a very good investment. However, they don't specify where this number came from. So please, could you explain how the Si2 camera could save an average of £29,500 a year?
Yeah, certainly. I mean, from what we do within the businesses, we're very big on return on investment. And acoustic imaging has proved to be, in certain cases, a very, very fast return on investment. Mm-hmm. From my personal experience, I've been involved in some demonstrations of this camera, the Si2, even within the last 6 months, where within less than an hour, we found thousands of pounds worth of leaks.
Yeah.
On larger scales with specialised gases, those numbers are going to multiply substantially. I mean, if you think about, your average sized manufacturing unit is going to have literally hundreds and hundreds of potential leak areas, such as connections and terminations and areas where you can have problems. So those costs are realistic in regards to the type of gas you're looking at, the size of the customer, how long the test was done over. In some cases, you may have case studies that have run over weeks, if not even months in some cases. Mm. My personal experience is always based on demonstrations, which may be 1 or 2 hours. But I've been confident enough in what I've seen. And on the back of those demonstrations, we've sold units to these customers, so they've also seen the benefit. Large savings really can be made, and whether it's a device, even if you're looking at the £15,000 mark, over a year, you could definitely be saving more than that. Depends on what type of leaks they are. And there are plenty of companies out there now who will have bad leaks and they're not aware of them because they're either out of hearing distance or they're in an environment which is very noisy. Mm-hmm. So, I mean, I'll give you another example. Personally, we visited a large glass producer to do a demonstration. And there was a leak in a air pipe which was near where we were standing, a bad one. Yeah. £1,500 a year it worked out at. But we couldn't hear it because of the environment was so noisy. But we found it with a camera by accident. We weren't looking for it. But the thing with these cameras are they have such a wide field of view that when you sweep around, you will spot things that you don't expect to see. Yeah. So then what the camera does, it prompts you to look closer. So even in that type of scenario, places where you wouldn't even look to find a leak, you will find leaks purely based on the ability of the camera to triangulate where that leak source is coming from. And it employs a series of sound filters. So it does it automatically. Yeah. The camera's listening to the environment and it's maximising the result that you get into the camera by its filtering out certain sounds to maximise the result.
So earlier you mentioned a little bit about the analytical function, so like quantifying leaks. Could you just explain a little bit more about those, please?
Yeah, certainly. Well, on the camera, you've got the ability within the settings menu to select we mentioned before about specialist gases. Yeah. So I'll go back to compressed air as an example. Typically, compressed air in this device is measured, leak rate is measured in litres per minute. Mm-hmm. So you'll have a litres per minute figure on the parameter for that particular function. Then you will have a kilowatt hour figure which you enter into the camera's menu. Yeah. So it will be based on a pence per kilowatt hour cost. Then it uses the sound pressure level, the leak rate, the time, and the kilowatt hour cost, and the specific power calculation which is already in the device. Yeah. And it will come out of a figure over a 12-month period automatically. Yes. Live while you're actually recording the leak. Now, those utilization times can be changed. So it can be days, weeks, months. It could be hours, days, weeks. It could be minutes, hours, days. So you can change. So if you want to do a bit of a test and see, okay, how's this performing over 24 hours? You can change the parameters just to show you, well, that leak in 24 hours is going to lose that much in both litres per minute and also in cost. Yeah. But that's the beauty of the device, is the flexibility is there to be able to do that.
And I suppose that's useful because then you can prioritise repairs.
Yes. I mean, I think what I've tended to find, so I've been in the industry for 25 years generally in technical sales. And I've spoken to maintenance departments for over those 25 years. And the one thing that is current and is typical now is that maintenance departments have to do more with less. Yeah. They have less people generally, and they generally have less budget. Mm-hmm. So any tools which are easy to use, but provide really powerful information.
Yeah.
They're the type of tools which companies will invest in because they do a job which is more valuable than the cost of the device.
Now, Mike, or rather Mike's boss, will be very pleased to hear that you can conduct inspections without shutting the plant down using an Si2 acoustic camera. However, Mike has some concerns about the accuracy of the camera and what it's like detecting small leaks. How would you answer his concerns?
Well, this is a fantastic piece of equipment, and it can detect down to very, very small leak rates. I mean, in fact, we've used this on vacuum applications as well, which the Si124 generally did not work with. So that's another indication that this is definitely a more sensitive, capable piece of equipment. So even with the minimum leak rate that we have in the specifications, which is 0.032 litres a minute, that's to quantify as well. So when we talked about how do you quantify the losses, the costs, but it will actually detect lower than that, but it won't have enough pressure to really give you the full result.
Okay.
But it would still find a small leak. This wasn't introduced to replace the traditional technologies. You know, ultrasound equipment is still extensively used, and it's this traditional type. You know, you will have an LCD screen on the back with some text and characters on. You won't have a nice 12 megapixel color image, but they have other capabilities that are outside the realms. Me personally, it's a lot faster than the Si124 because it's a more capable device. There's more processing going on inside the device. So the information that's being brought into the camera has got more processing to do. Even things like this partial discharge on screen analysis now, it's all done in camera.
Yeah.
So therefore, the capability of the device has been improved and has been speeded up.
To read more about how the Si2's analytical and accuracy functions, as well as its efficiency, could save you thousands, please click the link in the box above where you'll be able to download a spec sheet. Alternatively, if you want to know why they're so simple to use, keep watching. So far, we've established that the Si2 is cost-effective, it's precise, and it's efficient.
Yes.
But now I want to talk about how easy it is to use, because you see, Mike, he hasn't got time to do all these inspections himself, nor has he got time to train somebody up. So how easy is it?
I'll give you a real story. Okay, from last week. Visited a customer, food manufacturer. In this particular case, we were unable to get into the production area. So we were in the office and we had a good conversation for 10 minutes. And I showed the camera and I showed the engineer how to record an image. I said, okay, so do you feel confident enough now to go and capture some images? Because that's what's really going to prove the case. He said, yeah, I think so. And he went out and came back 15, 20 minutes later. He'd recorded 5 images. He'd added 5 comments. He'd saved them all. And that was after 10 minutes of me showing him what to do. So, do not underestimate how easy this piece of equipment is to use. It is very, very easy. But that is really a theme that runs through the FLIR range. Even thermal cameras, which can be complicated devices and the multiple settings and menus, our equipment is designed to be easy to use. So we're going to talk about how fast the device is as well. It's not about how fast does it capture the data. It's how fast you can get up and running with it. And it's quick.
Okay, well, I think you've convinced Mike. But Mike has got to convince his boss.
Yeah.
And the FLIR Si2 is somewhere between £14,000 and £19,000. And there are other models available, and they might be a little bit cheaper. So why should Mike's boss invest in an Si2? What should Mike say to him?
From our perspective, we have evolved this product over the last few years. Even something as simple as the fact that it's a single-handed device, that doesn't apply to all types of acoustic imaging cameras on the market. Some cameras you hold with 2 hands. Yeah. Now, some people may like that, and some people definitely don't like that. So even something like the form factor will be important in certain people's scenarios. Ours is a very nimble device. It's well balanced. The battery pack underneath means that it's carried out in the field. You know, you don't end up with an aching arm. You can still operate it with one hand if you press the camera button with your thumb. So technically it is a fully one-handed device. But it's also got the FLIR name on. And the expectation when something has a certain brand on, there's an expectation of quality, there's an expectation of longevity. And that's one of the things that you're investing in, because ultimately these are all investments people are making. Yeah. We all talk about buying products, but companies are investing sometimes huge sums of money But so from my perspective, it's you're invested in a quality brand. With that will come an expectation of performance and longevity. The ability to integrate our camera with our thermal cameras allows some customers to be able to combine reporting. But ultimately, it's a customer's choice. If you've got a limited budget and your budget doesn't stretch to a FLIR product, you'll look at another product. You may have another favoured quality brand product that you will opt for. Some companies favour certain brands. No different to people driving cars, whether it's Mercedes or BMW. They're both quality brands.
But I suppose what you could say about the FLIR product, though, is, as you've said sort of throughout this interview, is that it has been proven to be effective.
Yes. And that's, I can talk from my own personal experience. I don't use this tool on a daily basis to do a job. Mm-hmm. But I've done enough demonstrations since it was launched, which will be March last year, to have seen the benefits it can bring, to see customers investing in it because it does the job that we say it can do.
Yeah.
And then we prove it does.
Considering all that we've discussed today, is there anything else you want us to know about the Si2?
I think we've covered quite a lot today. I mean, the important thing is, I'll just go back to the easiest thing. It's easy to use.
Yeah.
So you can look at acoustic imaging camera and think, oh, that sounds a bit complex. The fact is, I look at thermal imaging as being like having a superpower, right? Because the superpowers essentially have an extraordinary ability. Being able to visualize things which are invisible and prevent machinery breaking down, that's like having a superpower. Being able to hear the sound of compressed air leaks or nitrogen leaks or CO2 leaks, that's also like a bit like having a superpower. So this equipment is by far and away some of the most useful technology you can use from a maintenance perspective and cost saving over time.
Yeah. And so if you were to sum it up in 3 words, what would they be? Fantastic.
Reliable. FLIR.
Thank you, Jason. That was very helpful.
Well,
Mike,
very enjoyable.
Mike will be thrilled.
Mike's no longer raging yet. That's the important thing.
Right. Remember, you can read more about all the FLIR Si2 acoustic cameras mentioned in this video by clicking the links in the description, where you'll also find an option to purchase. Do remember to look out for our other FLIR videos. In fact, if you subscribe, all future videos will come straight to you, so you'll never miss an important development. Right. Thank you for watching, and we'll see you in the next one.